Hi, I'm Phillips from the Planetary Boundaries Science Lab. Have you ever seen anything online about climate change and weren't sure if it was correct or not? Well, in that case, this video is for you.
I'm Stefan Rahmstorf. I'm a physicist and physical oceanographer by training, and I am head of the Earth System Analysis Department at the Potsdam Institute for Climate Impact Research.
So a common misconception I see online is people saying the climate changed in the past, so how can humans be responsible for climate change today?
The climate is determined by the incoming energy from the sun and the outgoing energy from long-wave radiation from the Earth into space. And whenever that radiation balance is changed, whether by natural causes or by human impact, then the climate will change. And the natural reasons in the past have been, for example, the changes in the Earth's orbit, the orbital cycles that have been known since the 1920s to cause the ice ages, ice age cycles every 100,000 years, and also carbon dioxide variations for natural reasons as part of these ice age cycles, for example, have changed global temperature. And now we are adding carbon dioxide to the atmosphere. It's now higher than any time in at least 15 million years because of our emissions. And because in the past the climate has always responded sensitively to these changes in radiation balance, they are doing the same now that we are changing the climate.
So I guess it's similar to someone saying lightning can cause fires, therefore humans cannot start fires, and we know that isn't the case.
Yes, I mean, if somebody concludes that climate does not respond to the changes we are causing because it in the past has always changed a lot, that is just exactly the opposite of what the paleoclimatologists like me conclude. We know how sensitively the climate has responded in the past, and it will do the same again now that we have changed the greenhouse gas concentration in the atmosphere. And in fact, we are using how strong these climate changes in the past have been. We are using those data to calibrate our models and test our models.
A myth you can often find on social media is carbon dioxide is 0.04% of the atmosphere. It can't have an effect on climate.
A small fraction of greenhouse gases can do 100% of the greenhouse effect because they absorb long-wave radiation, and all the other gases around them, they don't. And you can actually test this at home in your bathtub. If you just add an espresso cup size amount of ink to your bathtub, then that will be 0.04% of the water, but it will cause 100% of the blue coloring of your bathtub, showing that it affects the light transmission, just like the greenhouse gases do in the atmosphere. And in fact, of course, we measure that effect. That's not a theory. There is a global radiation monitoring network in different countries distributed around the planet, and there are satellites measuring radiation. And so we know exactly how much the greenhouse gases, especially carbon dioxide, absorb and radiate back to the Earth, and how that changes with increasing concentration. These are all just observational facts. And the long-wave radiation coming down from the greenhouse gases to the Earth's surface is actually twice as much as the solar radiation we absorb. So this is really a big knob that we turn there by increasing the amount of greenhouse gases.
So some climate myths can cherry pick what is actually accurate information, but it's what they've left out that is the important part. An example of this would be nature emits more carbon dioxide than humans. Can you explain where this comes from?
That is actually a standard fallacy that has been promoted already decades ago by the company Exxon in advertorials in major US newspapers. Nature turns over a lot of carbon dioxide because all the plants via photosynthesis are taking CO2 out of the air and using the carbon to build biomass. And then when this breaks down again, when the leaves have fallen to the ground and are rotting, etc., that carbon dioxide goes back into the atmosphere. But it's only CO2 that has been taken out of the atmosphere first and then going back into it, and that is a zero-sum game. It's just a turnover, and that's why the CO2 concentration in the atmosphere has been stable for 10,000 years before it started to dramatically increase by half, more than half by now, from the human emissions. It's because we are actually taking carbon, digging it up from the Earth crust in form of oil and coal and fossil gas, and adding to the system. And so if anybody says the emissions from nature are bigger than what humans are doing, they are confusing the turnover of a company with the net profit of a company. That is a pretty stupid thing to do.
So the key part then was that nature takes in its own emissions again.
Nature actually, because we are now adding a lot of extra carbon to the atmosphere, has become a net absorber of CO2. And about 25% of our emissions are going into the oceans, 25% are taken up by forests, and only about half of what we have emitted since the industrialization has stayed in the atmosphere. So the natural Earth system helps us by absorbing carbon. But it is not going to continue that forever, because that is mainly kind of surface systems, and the surface ocean, for example, saturates with carbon in a matter of decades, and also the uptake by forests will decline when the forests are coming under too much climate stress, by drought, by going up in flames. And so we cannot count on this amount of CO2 taken up by nature forever. So an increasing amount, an increasing fraction of what we are putting into the atmosphere will actually stay there, some of it for hundreds of thousands of years.
So a very common myth you see online is that volcanoes or the sun are causing current climate change.
Well, climate scientists, of course, have always been monitoring all these other contributing factors like solar activity, volcanic activity, the orbital cycles, and including them also in our climate models. The thing is, the effect of volcanic eruptions typically lasts for a few years only, because the material they inject into the atmosphere slowly comes falling down, raining down again. And solar activity is monitored and has been on a declining trend since the 1950s, and it has even slightly counteracted the warming that human activities have been causing. So it's definitely not the cause of the long-term global warming trend that we are observing.
So all of the natural factors that could potentially explain warming are either in the wrong direction or the wrong magnitude or size to explain current warming.
Yes, generally they are very small. The effect of volcanoes is small. Actually, volcanoes also emit CO2, but it's only humans are emitting like roughly 50 to 100 times more. So and the volcanoes, of course, have always done that, and the human emissions have now come on top since basically the 18th, 19th century.
A common myth that's also a cherry pick that you regularly see in winter online is it's snowing outside, what happened to climate change?
Well, it's a bit like saying I just had a great breakfast, so there's no hunger problem in the world. It's confusing local weather with global climate. And there is, of course, overall the snow cover on the Earth is declining because of the global warming. But you can get the occasional very strong snowfall, even exceptionally or record-breaking snowfall, because there is more precipitation in general in a warmer world. There's more evaporation from the oceans, more water vapor content in the atmosphere, and when that kind of falls out as precipitation, and it happens to be somewhere where that's below 0 degrees Celsius, then it falls in form of snow. And so we have seen some even record-breaking snowfall events locally, even though overall the snow cover and snowfall is declining in a warming world because a greater and greater fraction of precipitation comes down as rain rather than snow.
If you come across any more climate myths, maybe online or perhaps from an uncle, make sure to leave a comment below and we can make some more videos in the future. And of course, don't forget to subscribe to the Planetary Boundaries Science channel.